Hello, everybody, and welcome to SMART Talks. I'm Kimberly Datchick, the Curator of Learning and Engagement. SMART Talks connect research and art practice at the University of Iowa to the Stanley Museum's collection. Today's event is made possible in part by the generous support of Yvonne McCabe. This event is closed captioned. You can turn on the captions by clicking the closed caption button or selecting View Subtitles. The chat and Q&A options are open. Please add comments to the chat and questions to the Q&A. We'll answer all questions at the end of the presentation. Today, we welcome Terry Conrad. Terry is Assistant Professor and Program Head of Printmaking and the Iowa Print Media Faculty Fellow at the University of Iowa. In May 2018, Terry spent 10 days on a research vessel, the Robert Gordan Sproul, in the Santa Barbara Basin with marine biologists, chemists, PhD candidates, and the ship's crew. The lead scientist, Dr. Joan Bernhard, studies Foraminifera, surviving and adapting in dead zones or low oxygen environments. Foraminifera, or Forams as they're informally called, are single-celled organisms that are found in all marine environments. Today, Terry will discuss the opportunity he had to learn about this research and the artwork he made from that experience. Thank you, Terry.
Thank you, Kim. All right. Thank you, Kim, and thank you everybody at the Stanley Museum, and thank you, Yvonne McCabe, for making this happen. So yeah, Kim, very close. Foraminifera, yeah. So yeah, I'm going to talk I'm going to talk about this opportunity of in May of 2018 of going on a research vessel and sort of shadowing scientists and chemists and biologists and PhD candidates, sort of as they do this research on Foraminifera and sort of studying the water. And first, I just wanted to kind of talk a little bit about sort of the invitation. Years ago, something is not right with the PowerPoint. Okay. So years ago, I had an exhibition and I met a scientist named Dr. Samuel Bowser, and he actually taught me a lot about my work. And it was a really interesting experience because he saw connections that I didn't know about. And we developed a friendship and kept in touch. And occasionally I would ask him things about science and get some feedback about biology and chemistry and things like that. And he was a really great resource. And then a scientist asked him if he knew any artists that might be interested in working on a project and it would be a good fit. See, Dr. Sam Bowser is kind of a matchmaker for artists and scientists working together, it turns out. And he introduced me to Dr. Bernhard from Woods Hole Oceanographic Institute. And, you know, it was a really wonderful opportunity that sort of fell on my lap, and then it totally changed the course of my work. This is the first image of kind of sort of out at sea. I'm going to talk a bit more about this in a bit, but here, this is a piece that I made in response to this experience. It's called Biomarkers. And biomarkers is a scientific term that sort of deals with the idea of a trace of a foreign substance. And what we mean by that is oftentimes we're talking about something that's sort of anthropogenic, which is a pollutant originating from humans. So first off, before sort of going into talking in detail about what happened on the ship, I want to tell you a little background on some of my work and what I was making previous to this experience. So I make a lot of work using cans, just simple tin cans. And I cut open my first can probably 13 years ago. And constantly been kind of playing with them, and the experience has sort of evolved. I guess the reasons for using cans were initial just that they were around, ubiquitous, easy to find. Then it turned into this material I could play with. I pull them out of a recycling bin, cut them up, and if something's not working, they go back into the recycling bin. Metals in recycling is really great as opposed to plastic, because there's a very high percentage that can be actually recycled as opposed to plastic. So there is kind of a little bit of a drawback about these materials, cans. The insides, these beautiful colors, and that they're often lined with acrylic or polyester, which that is not supposedly a problem in leaching in the foods, but there are some issues in some cans still that they carry BPA, which is basically a chemical that can leach into food and is known to cause some ailments. So the process of making these forms was really intuitive at first, playing, building, cutting, and bending these cans to build these sort of larger vessels that I would print with. That previous image was essentially the plate that, one of the plates that prints something like this, or this. And so this is the machine, or the printing press, that I've sort of been, these tools that I've been building over the past few years, kind of developing it. And really, prior to this going out on the research voyage, this work was really kind of about more geological as opposed to biological. And so they kind of, to me, are these time-based objects that deal with sort of geology. I really enjoy sort of the opposites that are created, all this pressure to make this print, but the opposites of it being a slow process where all these tubes go down to the base. If you look at where the paper is here on this print, down on the floor, the architecture sort of drains all and goes down into this base, this open bottom vessel, which are these sort of cans. And I like that they're slow, fast, in one breath, they take, 3 or 4 days to make a print. That is a slow, inefficient print. But then also, in the grand scheme of things, 3 days is not that long. I like the idea of the control and chance that are in these works. I like thinking if maybe are they alive or dead? And here's another print. So on to meeting Dr. Joan Bernhard. Here she is drawing a picture, sort of. This is in the lab on the ship. And I'm going to go into more pictures of on the ship soon. But Dr. Bernhard is a senior scientist at Woods Hole Oceanographic Institute. And she's a geologist, geophysicist, but also studies cell biology. And she's been studying these microorganisms, the Foraminifera, for about 30 plus years, and specifically in the Santa Barbara Basin where we traveled. So a little bit about Foraminifera, or informally called Forams. There are many different species of this organism, and they're really sort of fascinating. These are 3 different types, and these are mostly coming from images of Joan's that are Dr. Bernhard, who were their electron scan microscopes images. And so basically the ones that we're looking at here, these sort of grow in these little spurts of secretions rather, of calcium carbonate. Here is a different kind of Foraminifera, they call it agglutinate, where it goes and grabs little sediment particles, like pieces and things that are in the ocean, maybe even pieces of plastic, little bobs and bits. So this is an agglutinated foram. This is an example of some of the prints that I made in this process. They are etchings, and the one on the left is actually made from mud that I collected when we were out at sea. And the one on the right is a combination of traditional inks and mud that we were out at sea. Now this is another sort of agglutinated foram. I really took to the process of making these etchings and these traditional prints. They were more of like my drawing process or my learning process. The opportunity to learn about Foraminifera. So forams are important to study because they are adapting to extreme weather change. Some of them are starting to develop their own oxygen down in the bottom of the sea, where oxygen is very low. In fact, they call them dead zones. So other forams are starting to steal organs from other organisms to kind of develop. And I sort of really kind of been drawn to these more agglutinated forams, where they're collected of many parts and things. A few more etchings, engraving. So I sort of think of them that they're changing the rules about survival by adapting to extreme change. And they're both creepy and beautiful. And sometimes I would just think about it, the surface, and try to emulate it in a silk screen, or actually draw the whole organism. Now, something that I wanted to point out that happened fairly recently, and I really enjoy this thought. I've been reading some books by Octavia Butler lately, and so I was sharing some interviews with my students on Octavia Butler. And one of the interviews, she mentioned something about early in her career, she read other science fiction to be inspired. And I thought that was really interesting. And because she went on to say later in her career, she read about science. And, I thought that was a really interesting educational thought as a product of going through art school, looking at art and kind of responding to art, but, taking the opportunity to learn from different disciplines to really develop my practice. So did a tour of Woods Hole Oceanographic Institute to see some of Joan's labs. And I was really in love with sort of the chaos of what happened in the lab and the beautiful colors that would be in the engineering section of Woods Hole, where it's just kind of the shipping equipment, the equipment for the ships. And this really sort of high-tech, interesting architectural tools almost that were used to learn about what's going on in the ocean. Beautiful objects. This is a really interesting, funny tool that I just find myself captivated by still. I think of it almost as a time machine. It's a machine that would actually take forams and turn it into fossils. And it's kind of, I love that this like working system here, because it's totally a mess. It's all over the place. This yellow container here is basically a place where forams would go, and then all this equipment, there's heat, pressure, physics, chemistry to kind of impose on these forams and with an attempt to turn them into fossils to understand something about their history. Because Foraminifera really hold an important fossil history in the sediments, and that's what we can really learn from. But they're also trying to just try to make fossils, just to make this comparison, to make comparisons. Now, I love how this is just an old board, and then it's just kind of this high-tech piece of equipment screwed into it. There's like stuff around. There's 10 different kinds of screws in it. It's just really, I can relate to this. So I wanted to share some of life on the ship. And for someone that doesn't go on boats and doesn't have much scientific education, it was a really sublime experience. The scale of the ocean and the financial expense of the research, the depth of education involved with the scientists, and just, first time in my life to be out at sea with 360 degrees of water, all to study this tiny, tiny organism that has some really, scientists believe, to have serious answers to global issues, global change issues. Now, of course, here is important to note where I slept in this time. This is the back of the ship where we spent most of our time. It's called the fantail. This is where the activity took place of all these research, these tools that were sort of stored and moved around. Now this crane would move around these big tools, and it was a really active space. And every time one of these pieces of equipment that went down into the ocean, it was called an event. So we started with event 1, event 2, anything that went into the water, it was labeled. So these tools, oftentimes what they did was they measured salinity, measured the saltiness of the water, and also these were tools to basically go down and collect mud at the bottom of the sea. The CDT machine, which is really a beautiful object. I got to be pretty intimate with it. This is one of the specific machines that check the saltiness of the water. And there's Dr. Bernhard. This is probably my favorite tool. It's called the MC800. And it's called the multi-core 800. And basically this goes down and collects mud at the bottom of the sea. So here it is, us doing an event, dropping it into the ocean. And so these are the cores, the detail of the cores, they're all numbered. So these plastic containers hit the bottom of the ocean, and then they slam into the sediment. And then the idea is that they pick up the bottom of the sea without disturbing it. So it's basically like a straw going into the mud. And so you see that top layer there, that's supposed to be an undisturbed surface. And this is where the Foraminifera live, in these top 4 centimeters. And so we would scoop out all that. The rest of this mud would be thrown back into the ocean. And what we would do is take these top layers and then put them into little vials. And obligatory boat ship picture of a cool door. The door leads into the lab on the ship. And there were several meetings. It was fun to kind of listen in and hear about different plans of different locations that they would travel to. We were about 10 miles out to sea, and then kind of going to very specific areas that the scientists have been studying the same location for years. I just loved on the ship how things were stored, like how the tape rolls and the rope was threaded and that, and the beautiful colors. So in the lab, we would actually start to take a look at the different mud samples immediately. And so this is, again, bringing up this image again. This is some of that mud that I was using for this large print. This is about a 44-inch sheet of paper. I think I was really fascinated with the schedule of all of us working together, and it was kind of long days into the night. You weren't quite sure what time it was, but the scientific crew working really tight and having many jobs. And I felt really lucky to actually get to be part of it and actually, be part of sort of the team of being handy and helping sort out. This is Helena and Shah. Helena is from Sweden and Shah is from China, both scientists. I wanted to show you this space here. This is basically a walk-in cooler, and it looked a lot like that. And this is where I spent most of my time, where I was sort of divvying out all the mud and putting it in different containers from the different events and really organizing it. I felt like I had a really important job, but it was sort of overwhelming because I didn't know what I was doing at all. But I kind of feel I can relate to to making inks and things like that and put them in this little bucket. So I was a little container. So I was kind of at home in some ways, but it was really cold. It's really funny to be, I was told that California had sort of the best weather, but I spent a lot of it in this walk-in cooler. Important thing to note is, we ate well on the ship. And it's interesting that the ship's crew and the scientists, there was very much a split. I really wanted to get to know the crew more, but it actually was difficult too, because we would eat at different times and they had different jobs and there was a real sort of focus. But that was a really interesting thing to learn about, because I also learned from Helena, who's a Swedish scientist, where that is very sort of an American thing, where we don't get together at first. Helena said in Sweden, they would kind of meet for a couple of days, all as a group, the crew and that, and understand what the research is, what the project is. So I was kind of, it was interesting to think about the separation that was there. So after this cruise is all done, all the mud, everything gets shipped back and goes back to Woods Hole, Massachusetts, the Woods Hole Oceanographic Institute, and is then, sort of researched. And actually, there was seawater brought back as well. And they're also sort of harvesting these to understand something about the generation of the Foraminifera. So, okay, back to my work. So this is the sort of time-based printing press that I made. And it was really, a lot of the elements in that are sort of inspired by things I saw on the ship. And it was even some sort of ways of just like the netting and the way things are stored. But I collected a lot of materials that were out on the ship, both out on the ship and also in Woods Hole. And here are some of the images that I made in this process. And what I found was, as I started working this way, I was kind of just imagining and thinking about some of the ideas of the forams. I wasn't necessarily making forams, but I was making these sort of maybe new creatures in this process. And I think that about them sort of as maybe there are these objects in the bottom of the sea, or maybe they're sometimes what it might look like looking through the microscope. And this is me installing this piece and just giving you a sense of how it works. I kind of feed it with ink and these handmade inks that I've been making from the collected materials themselves, and actually putting the ink into this machine, and it's slowly kind of going down to the base and printing over the course of time. And so there's this sort of slowness of the ink going down and traveling through the architecture of this tool. And so I've made inks from, this is actually a sort of a copper slurry, mostly copper, but this is sort of from collected metals from some of the tools that I pulled out of that was donated to me from, actually that were going into the trash at Woods Hole. And so this is some of the greens that you were seeing. And here in my studio at Oakdale, making some of the ink from the mud that was collected. And I want to just pop back to show you here some of these browns, these range of browns is what that Santa Barbara mud was making. And I was also, I had some seawater I was able to bring. I collected this mud and, I actually got rid of some clothes in Santa Barbara and packed my suitcase with containers of mud and brought it back. And so oftentimes you'll see these labeled containers, and these are the exact containers that we were using on the ship. And so this mud particularly was from 565 meters below sea level. So, this ink that I made, what I was making with mud was really, I kind of think of it as the furthest place to make ink from, to collect material from. And so then I thought a little bit about the opposite. I started collecting water from the Oakdale studio, and I would just fill these concrete bins with the water. And, this was I would just let them evaporate for a month, and there would be a mix of iron and calcium left deposited in these concrete pieces. And so this was actually the hot water, and then this is the cold water. And so then I would scrape out these bins, and here you see what some of the white tones are making, mixed with some of the mud and the oxidation of the cans on paper. The orange is the oxidation from the cans themselves. So really, I was coming up with a title. I actually consulted the scientists, and they actually titled the piece. And so it has a scientific name that means belonging to the sandy anoxic underworld, anoxic being lacking oxygen. And I always just say anoxiki because I can't say that first word. And I kind of like the idea now that I can't comfortably pronounce this. I wanted to tell you a bit about some of the outreach that I did in the past 2 years involved with this work. My partner started preschool years ago and did some projects, drawings, showing the students my etchings. This is an etching plate here, but then also showing them Foraminifera and making drawings. And they also were good feedback in helping me make the printing press from the collected items. Students, Kalei Blakemore and Casey Matthews and Professor Tom Christensen helped do a performance at a printmaking conference in Dallas, where we kind of told the story of Foraminifera, Dr. Joan Bernhard, and these tools on a bus traveling from one location to another. Clay did a great job playing Dr. Joan Bernhard. Another project that I did was working with a class at the University of Michigan, where I worked on these designs for a costume. The class was that invited me to come do a project was called Unfashionable, which was essentially a costume making class. And so I made these drawings and came up with this this sort of plan, and the students fabricated all the costumes. The costumes were designed to sort of work together as a system. And the characters were chemists, biologists, assistants, a lead scientist, Forams and Foraminifera. And so all the costumes sort of worked together to collect. The students prior, they collected water and mud. And what we did was process the mud through a whole system and through the bodies of Foraminifera costumes that the students made. And then printed forams on the sidewalk across the University of Michigan. And here's some of the stencils, the mud stencils that we use. So another project that sort of started out of this experience was these objects that are actually another kind of can. And I collected cans, and I still do, as I was walking into school. Collected cans smushed in the street and sidewalk as I walked into school. And I guess this sort of focus on Foraminifera, I started seeing shapes everywhere, and these shapes reminded me of Foraminifera on the ground. And so I started to make essentially the shells of these Foraminifera, or they also call shells tests. And I added foil as a layer, and worked into them with perforations, sorry, excuse me. And unlike the sculpture, they're light and small, and they can fit into an envelope. So I am excited to share that in the next year, not quite sure the timing now due to COVID pandemic, but I'll be going on another research vessel, at this time to the Gulf of Mexico. And I'm excited to sort of learn from this approach, which will deal more with chemistry and metals kind of existing and being a central role to microbial life. And the Gulf of Mexico is sort of has a major dead zone, a large dead zone, and it's sort of the mouth of the Mississippi. And part of the cause of this large dead zone is comes from the farming states, basically the runoff from fertilizers and whatnot going down into the ocean and creating algae blooms and choking out other populations. And so it'll be interesting to learn about that. I wanted to kind of end in conclusion with a few thoughts that I want to recommend this book. It's a 100-year-old book called Microbe Hunters by Paul Decreef. It deserves a longer conversation, but it tells the story of many scientists in history studying microbiology. So starting from the beginning. And in nearly every case, the larger scientific community didn't accept findings as findings were found. And oftentimes a a discovery was accepted maybe 100 years later. And it may have dealt with that the scientists at that time also, played a role of scientists and priests, or often the new knowledge was a inconvenient to the institutions in power. But this is a really fascinating book, and I think it's going to show up more in the next projects I do. So I think that this kind of research is important because it's introducing us to new audiences and introducing us to the sciences. An exciting part about this project is considering the conversation with scientists and learning about their research and the importance of it. Not only is this kind of research under discussed, but like artists, I think scientists also have a hard time maybe sharing their research with the general public. And so creating maybe a friction or a disinterest. Often in my classes with students, I like to talk about like, what's our job? What's our job as an artist? And I think through this, my job sort of evolved from where I was taking on this project, where I am, kind of learning and sharing, and the opportunity to be a student and respond and learn and then share the work. This experience got me thinking about larger issues. There's always the issue that I'm thinking about, biggest issue is climate change, but so the lack of understanding for the sciences in general. We're in a time where our leadership actually disrespects experts instead of creating an environment where groups of people can communicate and share knowledge. There is a larger divide being made, but I'm hopeful things are changing soon. We were taught to not trust our experts. And so hopefully that's turning around. And I just want to say to any students, if any of you are interested in this kind of research, I'd love to talk to you about these things, share more about the research and also maybe connections that I've made. But yeah, please reach out if you have any questions. Thank you. I'd love to take some questions.
Yeah, so people who have questions, please go ahead and add them to the chat or the Q&A. We have one question in the Q&A. It's from Sarah. It says, is the printing part, i.e. transferring ink to paper, important to your process or practice? Have you considered pigmenting pulp to make the paper through your press?
Oh, right, yeah. So yeah, the printing part, transferring ink to paper, important part to your process practice. Yes, absolutely. Well, so these objects, well, I guess I'll talk about it from sort of a more idea approach, where the process in time and mark making is really important. And I see like a link between mark on the surface of the planet, but also so the process of time also being important. And this object is like this sort of living being of, when you go into the space and you see this thing, it's kind of an active thing, making a mark in a slow sort of process. So transferring ink to paper, these materials that I'm using are objects, the objects themselves are the ink, are the thing that's transferring. So the idea, thinking about it sort of in a geological way, or time. So like this strata and tier and this pressure and fluid to sort of make a mark. Yeah, I have done some pigmented pulp printing. It's been a while since I did. In some ways, I think that it does happen when I print some things like sawdust and whatnot. But like, yeah, there's some previous works I could share with you that dealt more with actually grinding materials up and making inks that way. Hopefully I answered your question. Let me take a sip of water.
And we've got another one here. For your second research project, Voyage, what do you plan on focusing more on compared to your first voyage? What do you hope to further gain for your artwork from the trip? And thanks for your talk today.
Yeah, I think that I'm becoming more interested in, yes, making the objects. And I don't know how this is going to evolve yet, but I feel like more and more as time goes on, I'm kind of interested in the communication that happens on the ship, and being out there and, you know, sort of, you know, well, one, like the like working together as a team, but then also where it's smooth and where it's not so smooth, and what that microcosm of being on the ship kind of translates to the world. So I do hope that in the future, there'll be variation considering the social aspects of it, but I'm very much a maker of things. So, excuse me, I don't want to lose that either.
The process, as you talked about, it had so many different aspects: the research, the making the inks, making the prints, your outreach. It's almost its own ecosystem where everything's sort of related and overlapping. How do you think about that relationship between your printing, the research, and your outreach?
You know, it's funny because I think it kind of goes back to thinking socially, where I think there's probably a lot of answers to this question, but I do think that I love the idea of being a studio artist, but I also love the idea of teaching, and then also just working with people to work on something, letting things go out of my hands, and you know, work in getting other people's feedback to make decisions and how it sort of moves along. So I think, you know, working in the studio, kind of really focusing on materials, making ink or making this object, but then also sharing with a group to do sort of like a performance at University of Michigan with the costumes. And it's really kind of fun to think, you know, the job of what I'm doing, you know, and in the end, it's, you know, when somebody knows how to say Foraminifera, and or to hear, you know, people talk about the research and the importance of it, is really kind of like also the connection throughout it. Does that make sense?
Yeah, thanks, Terry. And I guess my last question, unless some other, I'll keep the Q&A open in case anybody has anything else as I'm asking this last question to you, Terry. One thing I found really striking on the ship, the instrument, the kind of time machine you called it, where it made the forams into fossils.
Yeah, so that is actually at Woods Hole. Still, that's in I was going to say Joan's studio, but it's in Dr. Joan Bernhard's lab. And so, yeah, so it's in the lab right now, and they're working it all out, actually.
Yeah, cool. It kind of reminded me of the time, the duration in your process of printmaking. Did you find unexpected parallels between the scientific aspect of the research and the voyage and your own practice?
Yeah, absolutely. You know, I think just that construction was really, I was really taken by sort of the craft of it, you know, where you know, if we can call it that, where it's like there's moments that are just like so incredibly engineered, and then some like really loose and immediate in doing the job. And I think also just maybe the way a scientist thinks of you know, it's different, but there's similar aspects of, say, repeatedly trying something. You know, I make the same thing over and over again to get it closer to what I hope it can do and does. And a scientist is asking different questions, but it's also changing variables very slightly to, you know, it seems so close to the last one, but it's a little different. To me, it would be the same experiment, but to them, just like temperature at 3 degrees high. I don't know, you know, example, but like just kind of the obsession. I really find the scientists sort of relentless sort of approach to you know, trying to figure out or try to get closer to it is just like fascinating.
Is there a place that people can go to see more of your prints from this series?
Sure. Well, so I have a new website coming very soon, terryjamesconrad.com. But then also on Instagram, I have quite a few prints at Terry James Conrad. But I also have a bunch of new work coming soon for a show in January. So in a month or so, there's going to be a whole bunch of new work. Yeah, I think we just got another.
Yep, you've got another question from Stephanie. Could you talk about how you conceptualize the different time scales in your work, Earth time, the way your pieces create time, etc.?
Okay, so I don't know. Can you elaborate on that a little? So let me try to see what an Earth time.
So she says, I'm thinking about how your pieces create over time and how you make inks and collaborate.
Okay. Yeah, what's that connection? Wow, that's like a nice thing to think about. So pieces. So I do think that in some ways, I'm like collaborating with this tool, but I'm also sort of learning it. You know, when I make a new plate or a structure to printing press to print with, it's this evolving process. And I think the same thing happens with, say, working on designing the costumes. It was, you know, maybe a month and a half of making drawings and doing little conversations about the research and that, like checking in, where I print multiple prints with this machine, and I kind of look back at the last one to make the next one. And so it's one after another, where I guess, you know, collaborating with a group, it's kind of like the same way, where we're like checking in and responding, and then checking in and responding. Yeah. Okay. That's a nice thing to think about, though, too. So thank you.
Thank you, everybody, for coming to our event today. Thank you, Terry, for your time and for sharing your work. This was great to learn a little bit more about it and learn about the science behind it.
Cool. Thank you for having me. This is a really nice experience.